Hi, welcome back. I am Naren, and in this video, we will discuss problem 3 of practice session 3 of Kickstart 2022. The problem is GBus count, and this is the description for which we will have the notes. So, the problem talks about a road with the cities numbered from 1 to 3 from left to right, and we have G buses, that is N buses. Let's say it's numbered G1 to Gn, where each bus will visit a range of cities, say from AI to BI, including AI and BI. And we have such N buses. And the problem is given a subset of cities, let's say P. For each city listed in that P, we need to find out how many G buses will serve that city. That means how many will visit that city based on the range AI, BI given for each G bus. And the input will have the number of test cases, and there will be a blank line after each test case, and for each test case it will start with N, which indicates the number of G buses, and the next line will have 2N entries listing A1, B1, A2, B2 till AN, BN, indicating the range of cities for each G bus, starting with A1, B1 for G1 bus, ending with AN, BN for nth G bus. Then next line will have P, the number of subset of cities for which we want answers, and after that in each line we will have the number of the city for which we want the answer, starting with say C1, C2 till CP. And output will be case hash the test case number colon. Since we want answers for P cities, we will list GC1, GC2 till GCP as the final answer, indicating the number of G buses that can serve the particular city. Then about the limit, you note that the total number of cities is not given. But if you look at the values of AI, BI and CI, which indicate the city numbers, all of them are less than or equal to 5000. So we can safely assume that based on these two test sets, max number of cities can be 5000. So indirectly, it's as if it has been given as 5000 being the maximum number of cities. And the other one is, it's not clear from the problem definition whether AI can be greater than BI in the input. Even though the sample cases indicate that AI is less than BI always, I think we need to make sure that the other cases are also taken care of in the input. Let's look at the sample. In the first sample case, we have 4 number of G buses with 1525, 3035, 4550 and 1020 as the 4 ranges of the 4 G buses, indicating the number of cities that can be served. Then the output we want is for 2 cities numbered 15 and 25. For 15, you can note that the first G bus and also the last G bus can serve it, because 15 falls within the range of 1525 and 1020. Whereas for 25, only first G bus can serve it. So hence the answer is 2 and, because for 15 there are 2 G buses, for 25 there is only 1 G bus. And let's look at the code template. So we will read T, then go through each test case, reading N, the number of buses, and then we will read each bus range AIBI. Since there are two values for each bus, we will use a struct root with value A and B. We can use int16 because the max value of A and B are 5000, and in the loop for each bus we will read A and B for I bus. And we have P, the number of cities for which we need the answers, and we can have a vector for CP indicating the city numbers for which we need the answers and read it. And here we just have an output vector for GC for each of the city, and we print it at the end in this template. So let's look at the algorithm. Since we know that we can have only 5000 number of cities, we can have a vector of 5000 representing cities, so that in each entry we can track how many G-buses can serve that city. And while going through each of these G-bus range, we can update the corresponding cities that there is a G-bus serving it. That means, let's say when we read 15, 25, we can update the cities for numbers 15 till 25 and incrementing that number, indicating that there is one G-bus serving those cities. Then when we go through 30 to 35, again we go through the cities array from 30 to 35, incrementing the corresponding values. So when we go through all the G-buses, each value of cities will indicate how many G-buses will serve that particular city, indicated by the index of the cities array. So finally, when we have a list of CI, we can directly read the final value from the cities array. So let's look at the code for the algorithm. So we will have a cities vector of 5000 max, because we know the 5000 is the maximum number of cities, and since each value can be a max of the number of G-buses n, so we will use int16, and this is the code. So while reading the A and B of each G-bus, we can do the processing. So first we will read the G-bus AIBI, then we will take care of the values of AI greater than BA or BA greater than EI by checking those corresponding values and using start indicating the lower of AI and BI and the other one in end, so that while updating the cities, we will go through from start to end and corresponding cities entries will be incremented. So when we go to the end of processing all the G-buses, cities array will have the final answers. Hence, for the final answer of P cities, we will get the C of Y, which indicates the city number. So we will directly access the value from the cities array. Let's copy paste the code and run the sample test cases. Okay, it's test one running, completed, and the answers are 2, 1, 3, 3, 4, which is correct. Let's submit the attempt. Attempt 1 pending, it succeeded. Test set 1 and 2 passed, and the score we got 5 plus 12 for this, totaling 44 after problem 0, 1, 2 and 3. So even though our solution ran fine for all the test cases, you can note that A, B and C can have a max of 5000 as the value, and we have a cities vector of 5000. Can you spot any error in this logic based on the code that we looked at? Note that in our code for the cities values, we are still using the values that has been input, which is one index based. So that means all A, B and C, the city number can be 5000, and when it is 5000, what will happen? It will result in an error. So ideally this vector should have been 5001 to take care of the value of 5. Most likely the test case does not have a value of 5000 anywhere, hence our code worked, but it should have been 5001. And some of the tips based on the current problem: always be careful with 0 index and 1 index based values, particularly when you're using array and vectors, because most of the problem definition will talk about 1 index based value starting from 1. Whereas while using the vectors, we deal with 0 index based. Either have a sufficient size vector to use 1 index based values, or convert everything to 0 index based, and also while outputting the results you need to revert back to 1 index based values. Also try to reduce the problem space. In this current problem case, we have unknown number of cities, so the problem space becomes huge. But based on the other input values, we can make a reasonable assumption that it's only 5000. So try to make such reasonable assumptions to reduce the problem space so that we can optimize the solution, and also it can be run within the memory and time limits specified for the problem. Also remember that in real life applications, when you are working, we always try to come up with reasonable limits for inputs so that we can restrict the very big inputs for the safety and stability of the systems. So we won't just randomly take any size. So you can check the description for links to other problems of the session 3 of this practice kickstart, and I will also upload a separate video for the remaining problems. If you find this useful, please like, subscribe and share, and thank you for watching.